Hi, everybody. Thanks for joining us for another Azure Data Academy session. Our series here specifically talking about Azure Database for MySQL Flexible Server. And great to have you with us again today. All of our content is up at aka.ms/ADA for Azure Data Academy. You can find all of our series and also our upcoming sessions that we'll have published up there. Now, for those that are new and want to know more about what the Azure Data Academy is, we've got that here on our next slide. There you go. So our Azure Data Academy is going to focus all on the data platform in Azure. So SQL Server, MySQL, Postgres, Cosmos DB, all of our content will be related to the data platforms, mostly our operational data platforms. We recently did another series called Modern Analytics Academy, which is aka.ms/MAA. And that focuses a little bit more on the analytics side. So Synapse, data warehousing, Databricks. And so we thought we would separate that content out for kind of more of our operational data offerings. So you can find all of this content in our repo. The links are all here on the screen. And of course, we would welcome any feedback that you might have directly in our repo. Again, that's aka.ms/ADA. Or if you prefer, you can give us feedback through our Microsoft Office form, which is aka.ms/ADA-feedback. So on today's session, we've got Avnish Rastogi, who's going to be talking about high availability and disaster recovery in Azure Database for MySQL Flexible Server. And we know that this is a really important topic because obviously having high available services is critical for almost all of the partners that I've worked with. It obviously not just has an impact on availability, but also disaster recovery, so backups and backup strategies, and how that impacts cost and how that impacts RPO and RTO and all of that. So we wanted to have a conversation focused on that, and Avnish is going to go through what some of those core components are within Azure Database for MySQL. And if you have any questions on this content, leave them in the comments section, and we'll address them. And I know that I've gotten a bunch of questions that we'll be bringing up throughout this presentation as well. And so I guess we can just jump right into the material. Avnish, I'll turn it over to you, and I'll probably be interrupting you with some questions and clarifications as we go.
Yeah, no, thank you, Brian. So this is our third session in this series. In previous two sessions, we covered flexible server overview. And the second session, we covered another topic. So in this session, as you mentioned, we will focus on what are the different options we have to provide high availability and disaster recovery. So just to recap, in Azure Database for MySQL, today we have two different deployment options. Flexible server, which is the default deployment option. And second is the single server. Now, single server has been G8 for past 4 years. And we are planning to deprecate single server sometime later this year. So there would be announcement which we will send to all the customers. And in flexible server, we have three different service tiers: burstable, general purpose, and memory optimized. And we covered what are the different compute tiers, storage we support in each of these service tiers. So that's something can be reviewed in the previous recordings. Now, when it comes to business continuity options in flexible server, there are certain features which are available as a default in flexible server because it's a PaaS offering. And other options are configurable based on the customer requirements for the HADR. So first is backup and restore. Because it's a managed service, we do have auto backups. And the retention option for these backups is 1 to 35 days. So if it's a development or non-production database instance, you can retain these backups just for 1 day. But if it's a production database instance and you have a requirement to retain these backups for longer period, we support maximum 35 days. And in near future, we will have an option which would allow customers to retain these backups up to 10 years. And that's very critical for certain industry verticals like financials or healthcare. So that's something that's coming in near future. Now, all these backups are, we maintain 3 copies in the same zone where your database instance is provisioned. So if you select zone 1, then you will have 3 copies of these backups. And that provide another protection in case there is something wrong with one of the copy. So that's all behind the scene. The second option is the geo backups. So that's something you have to configure at the time of provisioning. Or later on, if you want to enable geo backups after provisioning, you can do that as well. And with geo backups, you will have these backups available in the paired region. So let's say if your primary region is East US2 and paired region is Central US for East US2, then we will copy these backups asynchronously to the paired region. And in case primary region goes down, you can use these backups to restore in the paired region. So that's a limit today we have, where we support only restore from the paired region. But in near future, we will allow you to restore in any region where this MySQL service is available. Now, from the HA perspective, we have 2 different options. One is the same zone HA. So in some regions, we don't have multiple zones. So in that case, you can still enable HA, and you will have your primary and standby database instance deployed in the same zone. And so you won't have protection from the zone failure, but it will still provide the benefits to minimize the impact from the Azure maintenance we do every month. And I will cover those in next couple of slides. Now, if you deploy your MySQL instance where we have multiple zones, you can select zone redundant HA, and you can specify where you want to have the primary database instance and where you would like to have the standby instance. So in case primary, there is an outage or there is a impact in the primary zone, we will automatically fail over to the standby instance. And because we have a DNS, we will update the DNS, and you don't have to update your application connection strings. So as long as your application has retry option, it will automatically connect to this new database instance. Now, lastly, we also have planned to have cross-region read replica, which is coming soon in next couple of months. And that's another option which you can use to enable the DR. Now, with cross-region read replica, you can provision read replica in any DR region. And if primary region goes down, you can switch your read replica to read write instance and update your application connection string. So that's a much better protection than the geo backups, but it ultimately depends on your application RTO and RPO objectives. So Brian, any questions on this slide before I move to architecture on these different options?
Yeah, no. I have a feeling we're going to come back to getting some points here and trying to get some more information on some of these. I think we'll probably wait until we look at some of the architecture to talk about it. But just to put it in your mind now is I'm curious with the difference, right? If we look at, say, cross-region, and you had mentioned this actually, which is what made me think of this, is specific with cross-region read replicas, the difference being the requirements of your RPO and RTO, right? Because obviously, if we're talking cross-region, that might be, let's just say my primary region is East US, and then I want to go cross-region to West US. Obviously, there's a higher degree of latency that is going to exist there. So I'm going to assume that in that case, that would be an asynchronous operation of copying the data. Correct me if I'm wrong, but then that would also, oh, I'm sorry, go ahead.
No, you're absolutely right, Brian. So if you have a cross-region read replica, when we have this functionality available, there are 2 factors which can impact your application lag. One is the region where you're replicating to. And second, so there is a network latency between these different regions. That's one factor. And second is the activity on your database instance. So if it's a extremely heavy write application, that will also affect the replication lag between your primary and the read replica instances. And there are 2 scenarios we have seen when it comes to failover. One is the planned failover. So in that case, you can monitor the replication lag. And when your replication lag is 0, you can switch your read replica to read write instance. And second is unplanned. So if it's an unplanned outage and you want to switch your read replica to read write instance, there is a potential for data loss, but that's something you can check based on the replication lag between these two instances.
Is it going to be possible to have multiple cross regions? So perhaps going from, continuing that example, East US to West US, and then maybe something in Europe, but can you have multiple cross regions?
Yes. So that's something we support in single server today. So in single server, we support up to 5 read replicas. And those read replicas could be in the same region as your primary instance, or could be in cross regions. And those regions could be any region where we have this service available. Now, one big change and flexible server is the number of read replicas we support. So in flexible server, we support up to 10 read replicas. So again, these read replicas could be in the same region or could be in different region where this service is available.
Great. Yeah, let's dive into some architecture, and then I'm sure that's going to tease out some of these other questions.
Sure. So this is the architecture of flexible server without any HA configuration. So we have in the middle compute where your flexible server database instance is deployed. And behind the scene, we use Linux operating system. It's a PaaS service, so you don't have to worry about the operating system as a customer, but just for the transparency, we use Linux Ubuntu operating system. And then you have the MySQL version 5.7 or 8.x. So that's something you can select at the time of provisioning. And underneath, we have premium storage, which we are using to store all your data file, log files, and temp files. So storage and compute has been decoupled, as you will see in most of the cloud deployments. And during the provisioning, you can select where you want to provision this instance. So in this case, we are selecting zone 1. Now on the application side, you have options to deploy your application on VM, on AKS, or app service. And in either case, you have the option to select which zone you want to use to provision your application. So with this architecture, it allows you to ensure your application and database instances are deployed in the same zone, and that will minimize the network latency and will give you the best performance experience. So that's the known HA architecture. And with this known HA architecture, we guarantee up to 99.9% uptime SLA. Now, as I mentioned that not all the regions in Azure had multiple zones. So one architecture or one HA topology is the zone redundant HA. So in this case, we have primary instance deployed in zone 1, and then secondary instance is deployed in zone 2. And again, you can select both zone 1, or you can select zone both for the primary instance as well as for the standby instance. So in this case, we have async replication between the primary and the standby instance. And when we do the failover, whether it's a planned failover or unplanned failover, we guarantee no data loss. And after the failover, we update the DNS. It's all part of the failover process. So there is no impact on the application connection string. And as soon as failover is complete, your application would be able to connect to the database instance. And we usually see 60 to 120 seconds failover time, depending on the activity happening on the database server. So usually it takes 60 to 120 seconds. Now with zone redundant HA, we guarantee 4 nines uptime SLA, so 99.99% uptime SLA. So that's one of the key difference between the known HA server and zone redundant HA server is the uptime SLAs.
And I think too, right? Just reiterating this, that you're also saying essentially an RPO of 0, right? The guaranteeing no data loss, which is awesome, right? That's kind of for a lot of, because I hear this from a lot of partners who are building solutions. One of the first questions I typically ask when we're architecting something is basically tell me about what your uptime goals are, essentially trying to tease out what the RTO and the RPO objectives are, right? How much time are you willing to be down and how much data are you willing to lose? And almost all partners that I work with will say, well, we can tolerate some downtime, but we really can't tolerate data loss, or we have to keep that absolutely at a minimum. We would rather have downtime. I think to be saying that there's an RPO of 0, I think is just a huge benefit.
Yeah, within the region, we guarantee no data loss, and you are absolutely right. Right, recovery from any data loss is very, very difficult for the customers. So that's one of the key advantage or differentiation we have here is that we guarantee no data loss as we do the failover from primary to standby. And like, again, regardless of the failover, whether it's a planned or unplanned failover.
So in looking at one of the and we might I might be jumping ahead a little bit, so if so we can come back to it. But in say a non-HA configuration, flexible server architecture where you're not doing this, having a synchronous replica is going to have an impact on performance. Do you have either guidelines or best practices or rough even anecdotes about the performance considerations of having essentially a synchronous replica in the same region but a different availability zone?
Yeah, so there is a slight performance penalty when you have the zone redundant HA configuration. So what we advise customer is to make sure we do the thorough testing. And mitigation for this could be that you allocate more compute, which will also give you more memory. So that's one way to address the potential performance on differences between the on-premise configuration and Azure when we are using the HA configuration. But again, it protects you from the zone outage. And we do auto failover in this case. So if there is any outage in the zone where your primary instance is deployed, we will automatically fail over to the standby instance without any data loss. And as long as your application has retry option, it will connect automatically once failover completes within 60 to 120 seconds. And another thing I want to highlight is that it also provide advantage or minimize the impact from the Azure maintenance we do every month. So when we do the maintenance, regardless of whether it's a zone redundant HA or same zone HA architecture, we always do the maintenance on the standby instance first. And once maintenance is completed on the standby, then we do the failover and do the maintenance on the old primary instance. So it reduces the overall impact of the maintenance we do on these database instances. But in case of same zone, the advantage would be that the performance impact would be slightly less because there is no network latency between these different database instances. They're essentially in the same zone, and it won't protect you from the zone outage, but it will provide you benefits or the reducing the impact of the maintenance we do, as I mentioned a few seconds ago. And uptime SLA in case of same zone architecture is 99.95%. So there is slight degradation in the uptime SLA compared to zone redundant HA architecture. So there's one more thing I want to highlight here quickly, which we didn't cover in this geo backups. So when you do the restore from the geo backups, what we have in the documentation that it can take up to 24 hours because we are restoring from the geo backups, and depending on the size of the database, it may take some time to restore. And there is a potential to lose up to 1 hour data. And reason for that is that because these are async copies, once a backup completes in the primary region, we copy those backups to the paired region. So it may take some time. Typically, we have not heard at least any customer complaining that we lost up to 1 hour worth of data. There would be some data loss, but it won't probably going to be 1 hour. It really depends. But I want to highlight here that it may take up to 24 hours to restore from geo backups and potential for 1 hour data loss. So that's where cross-region read replica is a much better option, especially for the tier 1 application from the DR perspective.
Yeah, absolutely. For certain, when essentially an RPO is you need that to be as low as possible, right?
Yeah.
That would be critical. Now, is that 1 hour latency? Is that because of the backup? Is it doing, say, backups every hour and then copying those backups? Is that what's going on?
No. So we do full backups every day, and then we do the transaction log backups or the incremental backups every 5 to 10 minutes, depending on the activities happening on the database side. But in case of restore, it really depends on the so like I expect to lose up to 1 hour data, but because it's a async copy, and depending on the activities on the database side, based on the testing we have done, we just put 1 hour potential data loss. And same is on the restore side. We depending on the point in time restore, we restore from the full backup, and then we apply all these transaction logs to bring the database to point in time or to the current state.
Using this, I mean, this is a this is a critical outage scenario, right, where there's like a catastrophic loss, right? This is not something you would be doing normally for.
No. It's a very, very unusual situation where we had a regional outage within Azure. So yeah, but we still obviously we have to plan for these very, very unusual situations. So there are two options from the disaster recovery perspective. One is the geo backups, and then once we have the cross-region read replica available, then that would be another option which customers can use to protect against the disaster within the primary region.
Mm-hmm. Is there any visibility into the backups? I know that, for example, with SQL Server or Azure SQL database, Azure database for SQL Server, I guess I should say, you can see the list of backups, right, as for a point-in-time restore. I imagine that's very similar with Azure database for MySQL Flexible Server, where it's a list, but you can't necessarily go into a storage account and enumerate the backups and the differentials and all of that, right? It's managed through the portal, and it's an abstraction right on top of that storage.
Yeah, so there we made some enhancement in terms of exposing these, providing more visibility on the backups. So one thing we did in the flexible server, if you can see my portal, that we have this separate category for backup and restore here. And when you click on backup and restore, I provisioned this instance just a few minutes ago before this call. You can see the list of backups completed successfully over the time. And you can also use this, so from you can see when this backup was completed, retained till, how long this backup will be retained based on the retention time you specify for your backups, and type of these backups, and the action. And action is basically, you can click any of these backups to restore from those backups. So that's something we provide this more visibility on the backup side. And then in the overview page, you have this restore option, which you can use to do the restore from the geo backups. So if you have enabled the geo backups, then you can restore to the paired region using those geo backups. In addition to that, you can do the latest restore point. So that's a point in time recovery. You can also select a custom restore point. So if you want to, let's say, restore 30 minutes from 30 minutes ago, you can specify that window. And then you have the select fastest restore point. That's basically based on the last full backup, we will restore from that point. So all these options are provided to provide more granularity or more options based on the recovery scenario. So hope that answered your question, Brian.
Yeah, that's great. Thank you.
So another thing I want to highlight here that until recently, if you have not chosen if you have not enabled the geo backups at the time of provisioning, there was no option to enable those post provisioning. Now, if you forget to enable the geo backups at the time of provisioning, you can still come back and enable the geo backups in the post provisioning. It might be it's somewhere in the either in the computer. I can check on that. But the point I'm trying to make that you can enable the geo backups after provisioning the database instance now.
Now, a question, and I don't know if you can be able to demonstrate this here, but because a common scenario obviously is that customers and partners are going to want to have essentially read replicas, usually cross-region read replicas. The scenario there is often to offload reporting query, that kind of thing, right? Not
Right.
so much for failover, but it's also can be used for that situation, right? So
Right.
how does, from a management standpoint, is failover handled automatically? Can you say turn it off, or how do you configure the failover policies?
So failover to read replica, it's a manual process today. So let's say you have primary instance and then you have a read replica. If primary goes down and you want to switch your application to this read write, then it's a two-step process. And certainly it can be automated. So first step is to stop the replication, and then your read replica will become the read write instance. And once that configuration complete, then you can update your application connection string to point your application to this new read write instance. So because each read replica has its own compute and own storage, and it has a separate endpoint. So in the replication window, I don't have any read replica provisioned here, but you will see that in the name, you will see the replication or the instance name, and then compute and storage you are using, the location where you provision the read replica, status, and availability zone. Now, when you provision the read replica, the compute and storage configuration would be same as your primary or master instance. But later on, you have the flexibility to change the compute. We don't recommend that because it can impact your replication performance. But you have the option to reduce the compute if you want to reduce the cost. Storage, obviously, you cannot change the storage, but on the compute, you definitely have the option.
Well, that makes a lot of sense, though, right? Because a lot of times the replicas don't need the same level of compute, even if they're getting used for analytical purposes. Oftentimes, their just needs are quite a bit different. So, in times where they're not being used actively for reporting, the compute needs are going to be a fraction of what they would be for the primary. So, I think that's nice to be able to do that and then scale it when you need to. For if there's a need to fail over or for some other reason, you can adjust it then.
Yeah, at least customer has the option to fine tune those. I mean, let's say primary is running on a 32-week core, and later on you reduce the read replica to 16-week core. The key metric to monitor is the impact on the replication lag. If you decrease the compute capacity and it is start impacting your application lag, then probably it's not a good idea to reduce the compute. But again, it depends on the use case and the tolerance on different use cases. And primarily, you have a couple of use cases or 3 use cases from the read replica. One is for the DR purpose. And second is if you want to offload read-only workload to these read replicas. And lastly, for the business intelligence or analytics. So these are some of the use cases we have seen from the customer for the read replica.
No, it makes a lot of sense, and I would imagine, just as you'd said, the type of workload is going to have the largest contributing factor into that, right? Especially if it's a very write-heavy workload, is going to need a compute level in the replicas probably very similar to what's in the primary. Versus something else that either read or even for analytical purposes. Yeah, it's good to be able to configure that because the higher level compute instances are not inexpensive. So that's a big factor, right? That goes into figuring out what you need from business continuity plan, but also how that's going to impact the cost. So that's something that they got to take into account when deciding how to best implement this for their solution.
Yeah, I mean, at the end of the day, it all depends on the business requirements. But we provide different options which customer can use to configure these database instances or read replicas. So they have complete flexibility on how they want to configure, whether it's HA, non-HA, same zone HA, read replicas, and all those things.
Very good.
So that's what I had planned to cover in this session. Brian, any other questions we need to cover?
No, I don't have any other questions. I think this was great information. If you're watching this on demand and you have a question, let us know in the comments or through the feedback form that we mentioned earlier on in the presentation. You can drop us a question and we'll follow up and try to get it answered. If you have a use case or example where you'd like some more information, we'd like to talk to you about it. So let us know and we'll explore it with you. But in the meantime, yeah, I think that will do it for this session. And I appreciate, Avnish, you taking the time once again to go through some of these for us. If you have anything, if you're watching this now, before we actually have the migration one, that we tend to get quite a bit of Q&A around that. So feel free to submit to us any questions or comments that you might have for that session. Do that now, and then that way we can be sure to address them in the session. For this session, I think that will wrap us up. And I thank everybody for taking the time to tune in to this session. And Avnish, thank you again for taking the time to walk us through it.
And thank you very much, Brian.
One final announcement, we're happy to announce a live session for Microsoft partners coming up on July 14th, 2022 at 1 p.m. Eastern. This session will provide a sneak peek at the current roadmap for MySQL, and we'll also take any questions you might have, and we look forward to interacting with you. You can register at aka.ms/MySQL roadmap. Please note that this session is for Microsoft partners under NDA and will not be recorded. When registering, please use your company email address, and we look forward to seeing you there.